Alright, this is your 6.4 notes. More polynomial equations, and one thing in particular we talk about in this section is a pretty important idea called the fundamental theorem of algebra. Basically what it says is whatever your degree of your polynomial is how many complex zeros you have. Complex meaning you could possibly have an imaginary part in your answer, or you may have a repeated, a higher multiplicity zero. But basically what this whole entire page here is saying is whatever your degree, n is your degree, n is how many complex zeros that your polynomial will have. Alright, so synthetic division, hopefully this is a review to you, but basically this over here to the left side is giving you the steps to do synthetic division. This is an example. I use a little bit of different notation when I do this. Instead of this, you'll see me do things like 3 with a box, and then a 2, a 0, a -9, a -27. I don't do the whole division bar with the plus signs. I just use negative to indicate negative numbers. And then I put a line down here. So what this is basically over here saying is make sure that you've got your polynomial dividing in descending order. So 3, there is no 2, so they're putting a 0 x squared in here. Okay, so 3, 2, 1, and then the constant term. So that's where this 2 is coming from. 2, 0, -9, 27. Okay, and theirs they're doing a 2, 0, -9, 27. Okay, and then the process, and then you can just read through this. You're going to pause it and write it all down. The process from there says just pull down your first term. Okay, so pull down that 2. That's what they did right here. Alright, and then multiply. 3 times 2 is 6, and put that product right here. So they're multiplying 3 times 2 and getting this 6. Alright, same thing I did here. And then from there you add. So 0 plus 6 is 6. Alright, 0 plus 6 is 6. And then you multiply again. So 3 times 6 gives me 18. So 3 times 6 gives me 18. Alright, and then they add again and get this 9. Alright, -9 plus 18 is +9. Alright, and then once again multiply again. 3 times +9 is 27. So 3 times 9 is 27. Alright, and then when you add those two you get a 0. Alright, so this is what my synthetic division is going to look like in the examples you see in the next couple of pages. This is what their examples look like in the book, and if you do, help me solve this. Okay, but this is again the way I'm used to doing it. So this is the way I'm going to teach it to you. But I just wanted you to see this is how your book does it. Now, what does this mean? This means this was a cube, so we go down a power. So this is a 2x squared plus 6x plus 9. Alright, everything is shifted down. So it went from a highest power of 3 to a highest power of 2. Alright, and then this is our remainder. There is no remainder, so we don't have to write the plus 0. Alright, so this is anything that precedes that 0. This is your constant term. Or if it precedes whatever this last number is, that's your remainder, but this would be the constant term no matter what that next to last line is. Alright, again, hopefully that's a review for you. Now, one of the things that's kind of weird about this process is we're used to, especially when you write it this way, that's kind of why I don't write it this way. We're used to the quotient going up here, but the quotient is down here when we're doing synthetic division. And what this means is that x minus 3 is one factor of this thing. Right, and our quotient 2x squared plus 6x plus 9, this is another factor. And if you were to distribute this and multiply this out, you would get right back to what we started with. Okay, you can multiply that and verify if you want to, but you will get back to this. Alright, so hopefully again review, come back and look at this over and over as you need to. We'll do a lot of examples, so you should have plenty of examples of the synthetic division process in this video. Alright, if x minus 2 is a solution to this, find the remaining zeros. So this is one type of problem that they give you. Whatever the solution is, that's what you're going to use to do your synthetic division. That's what's going to go in the box here. Alright, so this is a 1 x cubed, so I'm going to put a 1 here, a positive 8, a positive 21, and a positive 18. Alright, how do we start the process? Bring this first number down and then start multiplying. Negative 2 times 1 is negative 2. Adding these two gives me 6. Multiplying here gives me a negative 12. 21 and negative 12 combines to a positive 9. And then finally these two give me a negative 18. That cancels. Alright. So again, if this is a solution, if this really is a solution, then this should always sum to 0 at the end. If they tell you a number is a solution and you don't get these last two to sum to 0, you did something wrong in your synthetic division somewhere. Okay? Alright, find the remaining solutions. Remember, this is now a 1x squared. This was a cube, so this is a 1x squared, or just plain x squared, plus 6x plus 9. Alright, and that's the other factored piece. So since it's equal to 0, we set this equal to 0 as well. Alright, this will factor, so we got an x and an x, and we need two numbers that multiply to 9 and add to 6, so that's going to be 3 and 3. And then if I set each one of these equal to 0, I get x plus 3 equals 0. And then obviously this is the same thing, so I'd get that again. So our other solution is x equals negative 3. Now remember, fundamental theorem of algebra says that your solutions, x equals negative 2, the number of solutions you have should sum to the degree of the polynomial. This is degree 3. It looks like we only have 2 solutions, but again, this one's multiplicity 2. And that's why it looks like we're only seeing 2 here. This one counts twice because it's in both of these pieces. It solves each one of these. So this is multiplicity 2, this is multiplicity 1, and 2 plus 1 is 3. So we do get the 3 solutions the fundamental theorem of algebra says we should get. Alright, graphical methods. This means basically we're going to use the calculator to get that first solution. This previous example gave us a solution. This one's not giving us one. Okay, so we're just going to use the calculator to get the first solution. Alright, if they don't give us one automatically, we just use the calculator. So I'm going to plug this into my calculator real quick, this left hand side, and come up with that first solution. So I've got it in here. Okay, it says graphical, meaning it sounds like we're going to graph it. You don't really have to graph it. Just hit second window. That's your table setup. My table is set to start at -5 and go up in increments of 1 at a time. Okay, for right now, just set them to go up at 1 at a time. If you don't see any zeros, then set it to a half. Here for this delta table, this is the gap between the guesses, so you can set that to like a half or a quarter or something if you needed to, but for initially set it for 1 for whole number solutions to see if you have any. Alright, after you got this set up, -5, 1, both of these on auto, press second graph. Alright, and we're looking for the y column is 0. Okay, not the x column. The x column will always have a 0. Remember, the domain of the of a polynomial is all real numbers, so there will always be a 0 here. It's over here. Well, what makes this 0? So x equals 1 is a solution. Alright, so I'm going to use 1 to start my process. So 1, 9, negative 610, and positive 600. Alright, so there's my line to start the synthetic division. Bring this 1 down. 1 times 1 is 1. 9 plus 1 is 10. 1 times 10 is 10. Add these together, I get a negative 600. And then 1 times negative 600 is negative 600. Add these together, we get a 0. Again, if this is a solution, this should always be 0 here. I'm sorry, this is the coefficients of the other factor that's a degree less than this. So this is 1x squared, or just x squared, plus 10x minus 600. Alright, and that's equal to 0. This again is factorable, so we want two numbers that multiply to give me negative 600, and when I add them I get positive 10, and those two numbers are going to be 30 and negative 20. Okay, 30 plus negative 20 is 10. 30 times negative 20 is negative 600. So this, if this is set equal to 0, I get x is equal to negative 30. And if this is set equal to 0, I get x is equal to 20. Alright, so my three solutions, don't forget this one up here, or x equals 1, x equals negative 30, x equals 20. Okay, don't forget the one that you use to start the process. Alright, now this rational solutions test, I put it in here just because you might have some questions on your homework that deal with it. But with the calculator, the table method of the calculator, it kind of takes the place, or takes the need away from this. But anyway, the rational solutions, or another one's called the rational zeros theorem, another name for this. It basically says if there is a fraction or a whole number that divides, or that is a factor or a zero of this equation, solves this equation, then it's of this form: p over q, where p is a factor of this, or p divides whatever the constant is. I'm just writing p divides the constant, and q, this down here, is a factor of the leading coefficient. So q divides the leading coefficient. Alright, LC, leading coefficient. Again, you're going to use your calculator mainly, so it's not a huge deal that you know this, but if you're having trouble finding it, if it's not a whole number, then this is where this might help. You know, like if this had been like a 6 and this were, you know, a 5, then 6/5 or 3/5 or 2/5 or 2 or 3, or, you know, any of those things are things that it could possibly be. It's possibilities, right? And it's also plus and minus. It could be a negative version of that form. Okay, so what I'm telling you that for is I'm just going to let you combine 1 and 2 and use the table on the calculator to kind of take the place of 1 and 2 together. Alright, and then basically after you use that table, you're going to use synthetic division to come up with until you get to a quadratic, meaning the highest power is 2, and you keep doing it until you get to the highest power of 2, and then you use factoring or the quadratic formula to get those last couple of solutions. So again, it's something you could pause this and write these steps down, but after you see me do it a few times, hopefully you'll get the idea. Alright, so we're going to solve this equation. So I'm going to put, again, first thing you want to do is put it into your calculator to get that first root. Alright, so I've got it all in there. I'm going to hit second graph to go to my table, and again I'm looking for zeros in the y column. Now there's two zeros back to back, -2 and -1. So I'm going to write over here x equals -2 and x equals -1 are both zeros. So I'm going to start with this one. I'm going to start with the smallest one, -2. Alright, and bring down these coefficients. So 2, 10, 13, -1. Don't forget the negatives if they have a minus sign in front of them. Alright, and then I'm going to bring down the 2. So that starts the process, and then multiply gets me a -4. Add, I get 6. Multiply, I get a -12. Adding gives me a +1. -2 times 1 is -2. Adding gives me -3. And then -2 times -3 is +6. And then again I get a 0. Now I could write this out. So this is 2x cubed plus 6x squared plus 1x, or just x, minus 3. Okay, I could write that out and then rewrite it out again down here, but because this is going to be that, and because we know what another 0 is, we can just keep going with the process. Now I'm just going to, you don't have to do this. I am going to show you though that this -1 that made this equal to 0, I'm sorry, this -1 that made this equal to 0 will also make this 0. So just taking my calculator, plugging in a -1 everywhere I see an x. Alright, so I've got this function right here plugged in with a -1 everywhere. Oops. Everywhere there should be an x, and I need to stick in a cube. It should be -2, or 2 times -1 to the 3rd power. Alright, I think I got everything else in there, and I hit enter, and it makes this 0 as well. Okay, so -1 is a 0 of this thing as well. Alright, now again, the -1 was a 0 of the original. That means it's going to be a 0 of this. So what that allows me to do then is I can just put a -1 here, draw another line, and then just continue the synthetic division. Bring that 2 all the way down to here, and then -1 times 2 is -2. Add these two together. Alright, just ignore the fact that you've already done synthetic division. Try to focus on just these two lines. Gives me a 4. -1 times 4 is -4. 1 plus -4 is -3. And a -1 times a -3 is a +3, and that gives me 0. Okay, now I don't have to do it again. Alright, -1 times 0 is 0. That's going to bring me down. Again, this is the remainder. This latest line actually ends at this -3. So we don't worry about doing the next step. Okay, so this was our last line here. Alright, so that means now this was the cube, 2x cubed, 6x squared. So that means this is the quadratic. So this 2 corresponds to a 2x squared plus 4x and a -3. Okay, now remember, if this thing doesn't factor, and this one's not going to, then you still have the quadratic formula. So if you don't remember the quadratic formula, you really need to study up on it, because that's something that you are expected to know by now. But if you have a quadratic, again, oops, set equal to 0, if this is set equal to 0, and it is, because we're finding where it is equal to 0, then the x's that make this thing equal to 0 are -b plus or minus the square root of b squared minus 4ac all over 2a. Alright, that's the quadratic formula. Alright, you need to have this thing memorized. And in this case, a is 2, b is 4, c is -3. So -b would be -4 plus and minus square root of b squared would be 4 squared minus 4 times a is 2, c is -3 all over 2a. Again is 2, so 2 times 2. Alright, and then from there it's just simplifying. -4 plus and minus square root of 4 squared is 16. Minus a minus is a plus. 4 times 3 is, or sorry, 4 times 2 is 8. 8 times 3 is 24. and then 2 times 2 is 4. Alright, minus 4 plus and minus square root of 16 and 24 will combine to a 40 over 4. And you need to learn how to simplify radicals. So 40 is not a perfect square, but 4 is, and 4 divides 40. So I can rewrite the square root of 40 as the square root of 4 times the square root of 10. And then say that that square root of 4 is 2, so that 2 times the square root of 10 over 4. Alright, and then the last thing, because all of these are even, I'm going to divide everything by 2. Alright, and say that this is negative 2 plus and minus the square root of 10 over 2. Alright, so our overall solutions was that negative 2 and negative 1 to begin with, and then these other two, and then that completes it because it was a degree 4. So x equals negative 2, x equals negative 1, alright, x equals negative 2 minus the square root of 10 all over 2, and x equals negative 2 plus the square root of 10 all over 2. There's my 4 solutions. Alright, complex solutions. So, again, if we have complex solutions, it means it has an I in it, where I is the square root of negative 1. So, just like before, I'm going to start this process by coming up with a 0 of this original polynomial. So, put that into your calculator. Right, whatever was there before, clear it out, put this new one in, so x cubed (2x squared minus 3). Alright, go to my table, second graph. There's a 0 again. X equals 1 is a 0, this thing. So I'm going to use 1, and I'm going to say this is 1x cubed 2x squared. Alright, notice we skipped the x. Alright, so don't forget that. There's 0 x's. So I need to put a 0 here, and then a negative 3. Alright, don't forget those fill-in zeros that are sometimes needed if it ever jumps over anything. Alright, 1 times 1 is 1. 2 and 3 adds, or sorry, 2 and 1 adds to 3. 1 times 3 is 3. 0 and 3 obviously adds to 3. And then one last time, 1 times 3 is 3, and those add to the 0. So this was a cube, so this 1 corresponds to 1x squared plus 3x's plus 3. Alright. And again, you can try it, but this is not going to factor. So you're going to have to go to the quadratic formula. Minus b this time is minus 3 plus and minus the square root of b squared is 3 squared minus 4a is 1 this time, and then c is 3 all over 2a. A again is 1, so just a 2 on the bottom. Alright, so to simplify, we get a minus 3 plus and minus, and here's where our problem comes in. 3 squared is 9, minus 4 times 3 is 12. So we're subtracting more than we have. And what you've got to do is discipline yourself and be confident in yourself enough to know that you set it up correctly. So if a negative sign appears underneath that radical, you're confident in keeping it there and knowing that there's not a mistake that you made. It's fine if a negative shows up here, as long as everything is set up properly. Alright, now because we can't simplify that down anymore, the square root of 3 is not a perfect square, and there is no perfect square factors. The only thing we can do is just use this fact, that I is equal to the square root of negative 1. So I'm going to put an I out in front of this, negative 3 plus and minus I, right, times the square root of 3 over 2. Right, and then there's our other two solutions. Alright, so there's 1. Alright, and there's supposed to be 3. There's 1, 2, 3, plus the minus. Alright, so our three solutions are x equals 1, x equals negative 3 minus I square root of 3 over 2, comma, x equals negative 3 plus I square root of 3 over 2. Alright, and then one thing to note here, if there are any complex solutions, they always come in what we call conjugate pairs. Okay, meaning if negative 3 minus I square root of 3 over 2 is a solution, then negative 3 plus I square root of 3 over 2 is going to be a solution. Alright, if A plus BI is a solution, then A minus BI is a solution. Alright, conjugate means everything stays the same except that sign in between the two numbers. Alright, then here's an applied problem. So the weekly profit for some product is this. Alright, it's measured in thousands of dollars, and X is measured in thousands of units. Okay, so make sure you make that adjustment when you answer your questions on your homework if you have something like this. Alright, graph the function using a window and find one x-intercept. So all we're looking for is a single x-intercept. Alright, so I've got it in here. I hit graph. So there's what mine looks like. And oh yeah, by the way, my window is 0 to 50 because it says up to 50,000 units, and X is thousands of units, so that's 50,000. And then my Y min was negative 100 to positive 500. Alright, for the Y's. Make your Y scale 100, make your X scale 5, and your graph will look like my graph. Alright, now what am I doing? I'm trying to find a 0, one of the x-intercepts. So hit second, trace, 0 are the x-intercepts. Alright, oops, second, trace, option 2. Left bound, there's my cursor. Left bound, just get, there's about the closest I can get to the left of where it crosses, hit enter. Right bound, get to the right of where it crosses, hit enter. And then guess, just get as close as you can and hit enter. So x equals 20 is my first x-intercept. Alright, use synthetic division to find a quadratic factor. So 20 is one solution, so I'm going to start with that. I got a negative 0.1, an 11, a negative 80, and a negative 2,000. Alright, bring down your negative 0.1 to start off. 20 times negative 0.1 is negative 2. 11 plus negative 2 is 9. 20 times 9 is 180. Alright, then negative 180 plus 180 is 100. And then 20 times 100 is positive 2,000. Right, positive 2,000, 2,000 wipe each other out. So there's my quadratic. So this is negative 0.1 x squared plus 9x plus 100. That's my answer to part B. So this is a quadratic factor of that original. Alright, now part C says find all the zeros of P of x. So we've got a quadratic, so we can use the quadratic formula for the rest of it. Alright, minus b would be minus 9, plus and minus the square root of b squared is 9 squared, minus 4a is negative 0.1, C is 100 all over 2A, which is negative 0.1. Alright, 9 squared is 81. Negative times a negative is a positive, and then 4 times a tenth times 100 is 40. And then on the bottom we've got that negative 0.2. Alright, then negative 9 plus and minus. The square root of 81 plus 40 is 121 over negative 0.2. And then 121 is a perfect square. That's the square of 11. So the square root of 121 is 11. So we're going to add and subtract 11 to negative 9 and divide by negative 0.2. Okay, so that means that one of our solutions is negative 9 plus 11 over negative 0.2. Alright, negative 9 plus 11 is positive 2 over negative 0.2. Alright, and then moving this decimal over, that gives me 20 over negative 2, which is negative 10. Alright, and then another solution would be taking that, instead of a plus, doing a minus, so negative 9 minus 11 over negative 0.2. Negative 9 minus 11 is negative 20 over negative 0.2. Same thing as before, that's negative 200 over negative 2, which is 100. Alright, now, if you remember, x is way up here. X is the number of thousands of units produced and sold. Okay, does it make sense to produce negative 10,000? No. So we wipe that answer out. And so 100 and 20 are the two zeros that make sense. So technically this is C. Answer C would be x equals negative 10, 20, and 100. And then D, the production levels that make it break even, are 20,000 units and 100,000 units, because again the third zero doesn't make any sense.